Okay, I think this is going to be the last video in the data unit. So this is essentially consolidating all the stuff we know we can do with stem plots and box plots, and in this little bit we're going to be looking at when we're comparing two sets of data to each other, but it's important that the data it's the same type of data, but we can essentially compare two groups with how that data sits. So the first thing, back-to-back stem plots. Since you already know how to do an ordinary stem plot, this should seem quite intuitive. So before, when we had our numbers, I'm just making this up, we had a key to tell us how to read it, and we had, let's not do that, 3, 6, 7, 2, 8, 9, whatever it is. We were just looking at one set of data. With a back-to-back stem plot, this would be one lot of data, one group of data, and the back-to-back bit essentially, so we have our data going in this direction, but then to compare this data group to another data group measuring the same thing, we do a second stem and leaf plot, except in the mirror half we do the second group going out this way. So 2, 2. So from smallest closest to the middle, going out that way, and essentially it lets us see where the data sits in the same way that we had originally, but we can compare the two data sets. So the worked example in the book is looking at two groups of people who were compared when given a particular drug and asked to perform a task. And looking at the back-to-back stem plot at the top of page 31, you can sort of see how the drugged people on the left are much more spread out compared to the non-drugged people. And it's just a way to compare two similar sets. We might, another sort of example of doing this would be if we measured everybody's height in the class, and we had all, say, the boys on one side and the girls on the other. We might expect that the boys would all be slightly taller and the girls would have a cluster down here. So it's that kind of thing. So considering you know how to do this side of a stem plot, this is just the same thing except mirrored going that way. And it allows you to compare the two sets. For side-by-side box plots, and I don't really like this name, and you'll see why, because side-by-side would sort of mean here's one thing, well, here's a whiteboard marker, and then inside there's another one, but side-by-side box plots are above and below each other. So essentially what we would have is our scale. We'd have one group in a box plot like this. So this is our scaled thing, and the second box plot might look like this. And then we can sort of compare this group to that group. So on average this group was bigger, or had higher scores. This group was slightly more spread out than this group. And since you know how to draw one box plot, you can also draw another box plot but the important thing is that they are both on the same scale so that we've got a point of comparison. And then once you have those, you sort of need to interpret them in sentences. Okay, so we have one final example in which we have to do a back-to-back stem plot, find the 5-figure summaries for both sets of data, and do the box plots. Come up with a summary of the findings and then give an opinion. So this example compares 2 brands of nails and they are tested for shear strength. So I think that's like the breaking point. If they're bent or twisted. So it's the breaking strain is recorded in newtons. So we've got Holdwell and steel fix. I'm not going to write out the data, but I will do the back-to-back stem plot. Okay, so Holdwell, there's our 18, 19, 20, 23. So the key is 1, 7, line 2 equals 172. And over on this side we've got steel fix. Okay, so I'm going to do steel fix first, simply because it's in the direction that we're normally used to. So what I will do is I'll just go through the data, I'll write them out of order, and then once I've got all the data that belongs to each group, I will rewrite it in order. So our first one, 183, 195, 183, 199, 197, 201, 193, 194, 204, 197, 196, 193, 195, 211, 197, 187, 196, 193, 188, 189, 204. Right, so before I do the other half, let's just put these in the right order. So, looking at this, we've got a 3, which needs to go there, the 7, so we just need to fix those. 3, 5, 7. Here, if we just swap that 1 and that 4, and here we've got 3, 3. Let's just write it down here. 3, 3, 4, 2 5s, 2 6s, 3 7s, no 8s, and 1 9. So let's rub all that out. 3, 3, 4, 5, 6, 6, 7, 7, 7, 9. Okay, so that's the steel fix one completed. So now we'll look at Holdwell, and I'm just going to do the same thing. 0, 207, 175, 200, 206. I hope I left enough space for myself. 2, 220, 209, 209, 3, 7, 211, 23, 5, 97, 17, 3, 210, that's a 0 there, 204, 6, 9, 207. Right, so let's just reorder these. Those are okay. So we're ordering from smallest on the right, going that way. 04 is good. 2, 3. So essentially 637. We want 3, 6, 7. Let's do this one. So we've got a 0, 1, 1, 7, 0, 1, 1, 7. They're okay, so we've just got to do this one. And again, we've got 0, 4, a 6, 1, 2, 3 7s, and 2 9s. 0, 4, 6, 7, 7, 7, 9, 9. There we go. So, as you can see, SteelFix, most of the data is sort of all clustered in this little area here. Holdwell, their data is a little bit further up the scale, but they have more values at this top end and more at the lower end. And because these numbers represent the breaking strain, so that essentially means out of all the nails tested, and there are 1, 2, 3, 4, 5, 6 was it 24 nails of each brand, 2 of these broke at 175 newtons, whereas SteelFix, they needed 183 newtons to break even their weakest nails. SteelFix, their best nail broke at 211, but Holdwell have nails that can withstand 253 newtons of force. So you can sort of see that SteelFix, most of their data's here. Holdwell have a slightly more data at a slightly better breaking strain, but Holdwell is a lot more spread out than SteelFix. And when we do, we're going to do box plots of these of this data as well, and hopefully that will be reflected in the diagram once we see it. So from here, we need to find the minimum, the quartiles, the median, and the maximum, both sets. So what I might do, let's do a little table up here. We'll call that Holdwell, SteelFix, min, Q1, median, Q3, max. Let's just do it like that. Okay, so we're just reading straight off the values. The smallest value, 175. And the max value, 253. So I'm doing the easy ones first. SteelFix, the minimum, 183. The max, 211. So what did I say? We had 24 bits of data. 24 equals the 12.5th position, so it's going to be between 12, the average, the mean average of the 12th and 13th bit of data for both. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our median is there. And over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So our median is there. So don't get confused. This one, the numbers get bigger going that way. On the mirror side, you've got a count going that way. So our median here is the average of 195 and 196 for steel fix. That is 195.5. And over here we have the average of 204 and 206. 205. Okay, so now that we've found the median, we have 12 bits of data in our lower half and 12 in our upper half. So we're looking for the average of the 6th and the 7th piece of data. 2, 3, 4, 5, 6. So that's our Q1 position. 1, 2, 3, 4, 5, 6. That's our Q1 there. So hold well, that's nice and easy because they're both the same. 193 and 193. Two lots of 193 divided by 2 is 193. Over here, it's the average of 188 and 189, which is 188.5. And then our upper quartile is the same again, except we're counting 6 from the top half. 1, 2, 3, 4, 6. So it's between 199 and 201. Equals 200. So that's for that one. And 1, 2, 3, 4, 5, 6. So it's between 209 and 210. So that's going to be 209.5. So now we've got these 5 figures for both sets of data. We can jump in and do our box plots. So I'm going to rub all this out. We don't really need it now that we've used it to get our values. Okay, so what did I do with the ruler? Oh, there it is. Okay, so we have values between, what's our smallest, 175 and 253. So how can we scale that? If we could go from 170 up to 260. Let's call that 170. 180, 190, 200, 210, 30, 240, 250, 260. So that should fit all of our data in between that scale. So I'm going to do this one first. Let's go in blue. So 175 is there. 193, that's 193, would be about there. 205. 209.5 is really close to 210. And 253. That's about there. There we go. And when you have more than one box plot, it's worth marking and labelling them. So that's Holdwell, and I'm going to change colour. Let's go red for this one. So 183 is about there. 188.5. Call it there. 195.5 is about there. 200 is there. 211. And what were they called? Steel fix. Okay, so I'm hoping now that we've plotted both of those sets of data on the same axis with box plots. Now notice side by side usually means laterally, but as far as box plots it's a vertical side by side. You can see how spread out the Holdwell data was, and remember we talked about that with the stem plot, and the steel fix data is much more narrow. So I think we could say that although Holdwell does have some stronger nails that don't break until they have a much stronger force put on them, and on average their nails are slightly stronger, because considering this is half of the nails, we also have some that are considerably weaker than steel fix's worst nails. Now, so because that's so spread out, we have a lot of variability between the strength of any random nail that you pick out of a box of Holdwell nails. Whereas with steel fix, because all that data is squashed into this little area, we can sort of say that the strength of steel fix nails is much more reliable and consistent, and if you pick a random nail from the factory, you're more guaranteed to get one that is in a consistent range. And considering half of the data is between 188.5 and 200, that's a much, it's very consistent. So these ones, steel fix, their nails on the whole aren't as strong as Holdwell, but Holdwell has this inconsistent, very wide range of strengths. So I suppose that's sort of trying to summarise what we can get from the box plots. In your opinion, which is the better nail for strength and why? Well, that's sort of an opinion-based thing, but I would say, if we're talking about for strength, I would say maybe Holdwell is better, because their median strength is better than steel fix's top 75%. And it's less than half of Holdwell nails are weaker or the same or less as 3/4 of the steel fix. So these ones are more consistent, whereas these ones have a greater range of strength. So I think if you were picking for strength of nail, you would go for this one. But if you wanted something that was more reliable and consistent, maybe this one would be the better pick. So it's all about interpreting one set of data spread to another. This one has less variability. Maybe depending on if you were banging nails on to put the roof on your house and you are worried that sheets of tin might fly off your house because of these weak nails, perhaps you might choose Steel Fix, knowing that even their weakest nails are going to be consistently better than Holdwell's weakest nails. Okay, I think that's where I'm going to leave it, and that's the end of the data unit.